In this video, we're going to see how to solve logarithmic equations. Um, logarithmic equations. Let me get a different color. Logarithmic equations. Our strategy is to isolate the log expression. It needs to be a log of a single expression, or a single log of a single expression. And then we're going to write in an exponential form, and then do any further work that we need to do after that's done. So in this first equation, it's the natural log of x equals 6, and we need to solve for x. Just as an aside, the natural log of x is equivalent to saying the base of the natural logs is e. So you could rewrite this expression as log base e of x. These are the same. So let's just do that. Log base e of x equals 6. Now the exponential form for this, we have this base e to the 6th power, that is the log, is equal to x. Another way to think about this is e raised to what power is x? That's what these expressions mean. Well, now we have this written. Let's turn that around. Say, well, x is e to the 6th. And that is a number. E is the base of the natural logarithms. So we're done. If we want to know what that is approximately, let's pull up a calculator and see what that is. E, and I think it's on here somewhere. Should be on here. E. There we go. E, you gotta hit the inverse. E to the 6 equals, inverse e to the 1. Oh, there we go. This is the answer. The power of e to the 6 is 403. Learn how to use my calculator. 403.43. And if I want to do 3 decimal places, 439. So there's our answer. It's not a real friendly calculator. Anyway, let's go to this next problem. Now here, we notice we want to isolate the log, and right now it's not isolated. Treat the log of 5x kind of like x, solving for x. So our first step would be to subtract 6 from both sides. That's going to cancel off 6, leaving us with 2 log 5x is equal to 12. Now, again, an aside, this is the common logarithm. If we don't write the base, that means that it's log base 10. So log of x is equivalent to saying log base 10 of x. If the base is not specified, it's a common logarithm, log base 10. So let's leave it in this form. Now we're going to divide both sides by 2. And we get log of 5x is equal to 6. Now, since this is base 10, we have isolated the log, and we can rewrite this now in exponential form. So this is equivalent to saying 10 to the 6th power is equal to 5x. This is a million. So we have a million, 1 followed by 6 zeros, is equal to 5x. And if we divide both sides by 2, or by 5, I'm sorry, we get 200,000 equals x. Okay. Going on, this problem here, we kind of have our logarithm isolated, but we do have this, there is this property of logs that says this: the log of p to the q power is equal to q log p. In other words, logarithms are the exponent, and if we have an exponent, we can bring that out front. This is a property that is quite useful. So what we're going to do to make this a little simpler is we're going to bring this 3 out front and rewrite this way: 3 log base 8 of x is equal to 12. And now, it's 3 times this log base 8 of x. Divide that by 3, divide this by 3, and we get log base 8 of x is equal to 4. And now we have this totally isolated, and we can rewrite now in exponential form. 8 to the 4 is equal to x. And we could leave it in this form, or we could evaluate 8 to the 4th power, and that's 4,096. All right, and on the last one, this is isolated when we have an expression, a log of an expression that is a sum or a difference. We can't break that apart, and only if there was a log out in front of this -1 and it wasn't in parentheses would that be legitimate to call that division. This is not division. So let's go with rewriting this in exponential form. What we have is 3 to the 4th power is equal to x squared. Let's just say that's just x squared minus 1. 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81, equals x squared minus 1. So we're going to add 1 to both sides, and let's put our x squared on the left. Adding 1 to both sides gives us 82. So x squared is equal to 82. 82 doesn't simplify. Divide 82 by 2, you get 41, which is prime number. So this is simplified when I go to this next step. I've got x squared is equal to 81, taking a square root of both sides. 82. taking a square root of both sides, I get x is equal to plus or minus the square root of 82.